The next lab that we're doing is going to be on the effect of gravity on falling objects. Now I know they fall down, but it would be interesting to see if there's any patterns to how they fall. What happens to the speed? Does it increase constantly, or does it increase more each time or less each time? Is there any sort of pattern? Is there any similarities between objects? So in order to start finding this out, we're going to use a technique called video analysis. I'm talking at my phone right now, which is sitting on the shelf of a locker directly across from me. And I picked that because it's really important to have a stable place for a camera to be. The camera is going to be looking at moving objects, namely this angry bird, as I throw it up and down. It goes up, it slows down, it stops, it comes back down. You know gravity was pulling it down, but that caused a change in motion. We had our initial velocity lost, it decreased, and then a new velocity in the opposite direction was gained.
Here it is again in slow motion, where I think the different speeds at different parts of the motion become obvious. We can use videos to study motion because of the way that video files are made. They're actually nothing more than a set of still images that are shown sequentially. I think the easiest way to demonstrate this is with something I hope you made as a kid, something called a flip book. Let's take a look at one. This is obviously nothing more than a very simple drawing where I've moved the ball from position to position between pieces of paper. But our eyes see it as motion. We see it as a movie. It turns out that the video files your phone produces are nothing more than this. And because in each picture that the phone takes as it makes a video, the object is in a different place, we can then use this to study that object's motion. We can actually do exactly the same thing to study the motion of the angry bird. This software called Tracker enables us to step frame by frame through this motion and see where the object is at different times. Using the position data generated from this video, we can then study the motion. We'll talk about how Tracker works in a separate lesson, but I want to talk in this video about how you set your phone up to record a video that can be used to study motion like this.
I'm talking at my phone right now, which is sitting on the shelf of a locker directly across from me. And I picked that because it's really important to have a stable place for a camera to be. The camera is going to be looking at moving objects, namely this angry bird, as I throw it up and down. And if there was any motion on the camera, we'd have trouble identifying whether it's the bird that's moving or the camera. So you have to find a nice stable place to do it. The camera itself is actually going to do all the timing for us, because as the video file is encoded, it encodes how many seconds there are between each frame in the video. So the only thing we have to really worry about is making sure that the video contains accurate distance information. So there's a couple things that we do to achieve this. One is I'm standing directly across from the camera. There's no sort of horizontal difference between me and the camera. Because if I was at an angle, the camera wouldn't be able to tell that. It would add measurement error. In addition, the camera doesn't know how far away I am, and it doesn't know how big I am. So what I need to do is put some sort of scale in the video. That's what this meter stick is. You can imagine that there's a plane that bisects me through my head like this, and all of the motion has to be in that plane for the scale to be accurate. Anything closer would be inaccurate, anything farther away would be inaccurate.
The most obvious way to see what I'm talking about there is to look at this ceiling tile. This is a square, but look what it looks like on this video screen. It looks like this edge is much longer than that edge. And that's just because of the way the camera lens records stuff. It distorts things. So it's really only for one distance from the camera that our distance data is valid. You can see here how the meter stick ends up being part of the file. We can tell Tracker exactly how long that meter stick is, and then everything that's that exact distance away gets scaled appropriately.
So now that I've explained this to you, the only thing I need to do is hold up my scale, and I'll move it around so that I can make sure it's on camera. I've got my Angry Bird in that same plane, and now all I have to do is give it a toss. And this is going to collect a huge number of data points in the short time that it's actually in the air. And that's it. Now we get to analyze the data.
Data analysis may seem a little intimidating. We will talk very specifically how to use Tracker in future lessons. I have a video I've produced that shows me analyzing this motion step by step. I also have screenshots so you can go along as you analyze your motion. The only thing I want you to be able to know right now is how you would film something that then could be used in Tracker, because that's what we're going to do next. One more thing about Tracker. Douglas Brown at Cabrillo College distributes this for free. We will have some copies on school computers for you to use, but you're welcome to get your own copy by going to this website and downloading it. It's available for every major operating system.